section 3.8, our objective today is I can find values of a function, state its domain, and find the value of composite functions. Now, first of all, what is a function? A function is defined as a correspondence between two sets. Or in other words, a relationship between two sets. The two sets are the domain, which we designate as D, which are your x values, and the range, which we designate with a capital R, which represent the y values that assign each member of the domain to exactly one member of the range. Okay? And basically, it's the idea that it's a rule that does something to the domain value and returns a unique range value. Okay? So really, we've already been doing things like this. So if x is our domain value, and y is our range value, then what we've been doing is we've been taking some rule, say this rule, and we've been plugging in an x value and getting a y value out. Okay, so if I plug in a 0, if I plug in a 1, and if I plug in a 2, okay, and so we see that for every domain value, there is exactly one range value that corresponds to it, or that goes to it. So every item in the domain, we say, maps directly to exactly one item in the range. So 0 maps directly to -3, 1 maps directly to -1, and 2 maps directly to 1. Okay, so when we write ordered pairs, the x value is our domain value, the y value is our range value. Okay, now we designate a function in several different notations. Your book uses this notation, and it's read all g that takes x to 3x. In other words, for any value you put into for x, you do 3 times that number and it gives you the result, which is the y value. So this says g is the function that assigns to x the number 3x. Okay, so the correspondence is that you're multiplying x by 3. Okay, another way to do function notation, and this is the more common way, f of x is equal to 3x plus 2. Okay, so that's the more common form. And notice that if I just replaced the f of x, if I just replaced that with a y, then we really just have the equation of a line there, okay? So f of x and y can be interchanged. If you're talking about a function, then you say f of x equals 3x plus 2. If you're talking about the equation of a line, you say y equals 3x plus 2, okay? So the graph of a function is the set of all points x, y, okay? Where, as I said before, x represents the domain values. In other words, the numbers you're allowed to use for x. So the domain value or the domain of the function. And y represents the range values. And so the whole set represents the range of the function. Okay. So example. If I have f of x is equal to negative 1/2 x plus 2 with domain 0, 1, 2, 3, 4. So this is saying the only numbers I can use for x are 0, 1, 2, 3, 4, which means I can't use any decimals, any fractions. I can only use those 5 numbers. So if I want the range, what I have to do is plug those in. So I do f of 0, okay, I do f of 1, okay, so that's negative 1/2 plus 2, so that's 1.5 or 1.5. f of 2 is negative 1/2 times 2 plus 2, so that's negative 1 plus 2 or 1. f of 3 is negative 1/2 times 3 plus 2, so that's negative 3/2 plus 2, so that's a positive 1/2 or 0.5. Let's write this as 3/2 and this one as 1/2. Okay? That way we're staying with the same type of numbers. And then f of 4 is negative 1/2 times 4 plus 2, which is negative 2 plus 2, or 0. So for the domain 0, 1, 2, 3, 4, our range values are the numbers 2, 3/2, 1, 1/2, and 0. Now if we graphed those, okay, I would have the ordered pair 0, 2. So notice that that's there. I would have the ordered pair 1 and 3/2. So notice where that came from. I would have the ordered pair 2, 1. So notice where that came from. I would have the ordered pair 3, 1/2. So notice that came from here. So these are all your x values. These results are all your y values. And then finally I would have 4, 0, okay, which again came from this and this. Now notice that I'm only allowed to use those values for x. So now if I go to graph those, um, 0, 2, over 0, up 2, 2, 1, 3, 1/2, oh, I missed 1 and 3/2, and 4, 0. Now I cannot connect those points, because if I connect them, I'm saying I can use a fourth for x, I can use a half for x, I can use 3/4 for x, but the domain doesn't include those, so I cannot connect the points. In fact, let's just get rid of that. Okay, so when the domain is specific like that, when you're given specific numbers, you cannot connect the points. Okay, so let's look at another example. Okay, number 2. If f is the function that takes x to 5x minus 1, and g is the function that takes x to 2 plus x squared, find f of 10. So that says in the f function, wherever there's an x, put a 10 in its place. So that has a value of 49. Okay, B. Let me go back to black here. Find g of 7. So that says in the g function, wherever there's an x, put 7 in its place. So here's the g function. So we have 2 plus 7 squared, or 2 plus 49, or 51. So 51, I'm sorry, 7 squared. Yeah, 7 squared is 49, so I get 51. All right. Now, the next example is what we call a composite function. It says find g of f of 3. Okay, so in a composite function, you work from the inside out. So you find f of 3. So f of 3 is equal to 5 times 3 minus 1. Okay, so that's 15 minus 1. Or 14. So what this says, remember substitution from geometry, f of 3 is exactly equal to 14. So in place of this f of 3 right here, I can replace that with 14. So now I have g of 14. Now that says in the g function, wherever there's an x, put a 14 in its place. So we have 2 plus 14 squared, which is 2 plus 196, which gives us 198. So g of f of 3 is equal to 198. Okay? So that's what we call a composite function. Now notice that if I go the other direction, let's do f of g of 3. Okay? So this one says, in the g function, well, let me write the functions here again because we can't see them. F of x was 5x minus 1, and g of x, remember this is another way to write function notation, is 2 plus x squared. Okay? So this one says, start with the g function and find its value at 3. So we plug in the 3, so we get 2 plus 9. And so that's 11. So that means in place of g of 3, we can put 11. So we can find f of 11. So that says in the f function, replace the x with 11. So we get 55 minus 1, or 54. So we get 54. Okay? All right, let's try another example here. Example 3. For the domain, state the range. Okay? So I have f is the function that takes x to absolute value of x minus 3. Okay? So if my domain is -2, -1, 0, 1, 2, okay? Then if I put -2 in for x, that's absolute value of -5, which is just 5. Okay? If I put -1 in for x, which gives me 4. If I put 0 in for x, gives me 3. If I put 1 in for x, gives me 2. And if I put 2 in for x, that gives me 1. So my range, is the set of 5, 4, 3, 2, 1. That's the range of that function given that domain. Now, we have to be very careful with domains sometimes, because remember, in the real number system, there's 2 rules we can never break. Number 1 is never divide by 0. And number 2, never take the even root of a negative number. Okay? And so by that we mean, for instance, the square root of -4. That's not possible in the real number system, so we can never, ever, ever do that. So what we have to do is make sure that we eliminate from the domain any numbers that would make us break one of those 2 rules. For example, if I have a function f of x is equal to 1 over x minus 3. Notice that if I put 3 in for x right here, that will break rule number 1. That will give me a 0 in the denominator. Okay? We can't do that. So we have to eliminate 3 from the domain. So we say that the domain is all x such that x cannot equal 3. Meaning I can use any other real number in the whole world that I want, but I cannot use the number 3. Okay? Another example would be g of x is equal to the square root of x minus 3. So the number underneath the radical, or the square root, has to be a positive number. So that means that the result of x minus 3 has to be greater than or equal to 0. So if I solve for x, x has to be greater than or equal to 3. So the domain, as long as the x I put in is greater than or equal to 3, then I will never break the second rule of dividing by a negative number. So if I put 3 in, I get the square root of 0. And the square root of 0 is 0, so that's fine. If I put 4 in, I get the square root of 1, and that's 1, so that's fine. But if I use any number smaller than 3, I will end up with a negative, so that breaks the rule. Okay? Now, final example, if I have h of x, and we can use any letter to represent a function, and my rule is 1 over x squared plus 2. Is there any number that I would put in for x here that would cause me to make my denominator into a 0? In other words, is there any number I can put in for x that will give me a negative 2? No, there's not. And so in this case, my domain is all real numbers. So my domain is all x such that x equals all reals. Okay? So that is basically what you need to do for this section. The key is the domain. Remember that you can never, ever, ever break this rule or this rule if you are asked to state the domain.